Hello guys, how are you? My name is Marius and tonight I'm going to show you how to program a 16F628 microcontroller. So you're maybe new on this microcontroller programming, and this 16F family is basically one of the most common families of microcontrollers from Microchip. So this type of programs, they usually have the name of Hello World or basic programs. For programming I'm using, as you can see, MPLAB. If you're wondering about the version, it's 3.35. So I'm not gonna go into the entire process of creating a new project right here, and how to start and how to connect your pickit programmer. There are a lot of issues on this, and there is also a lot of forum discussions about this subject. I know maybe I'll cover this in future videos. What I'm going to try to show you right now is how to create a very simple program, like just a few code lines, and with these lines our goal tonight is to be able to make some LEDs right here turn on. By the way, if you're wondering about my launchpad and how it works, I'll put a link into the description of the video pointing to my website, and you can access the schematic for this board if you're interested in this. So let's get started. I just wrote a first comment here. You can do without this comment. This comment only it's only for the user, so that I know when I look into the future at this program to recognize what's written in here. So every program that you write, it's going to start with a command for the compiler. Because I'm using this MPLAB environment, I have to write this. So I'm going to write reset code. That's a very short command for the compiler. Maybe I'm going to explain you what it does. The thing is that if you try to write a program in MPLAB before, you saw that the compiler doesn't actually run without this command. It's basically a command to help the compiler integrate the entire code starting with this line. To include the type of microcontroller into the library and not just make the entire program and the entire environment to search for the type of microcontroller, I will just write here like this: include, and the target, that would be, in our case, 16F628, and my type happens to be A. There are multiple types of this 628 microcontroller. Okay, now we're ready to go. We're just gonna write some configuration pins for this microcontroller. Probably there are some fuses that they need to be set in order to to have them to set these fuses when you program the microcontroller. One of the fuses would be, for instance, the type of external or internal oscillator you want to use for this microcontroller. And by declaring these fuses here, you don't have to set them again in the programming environment for the microcontroller. Maybe you're using PonyProg or some other ICProg or something like this programs. I'm just gonna program it using the MPLAB environment, as you will see. But it's always helpful to have these declared right here. So the first one I'm going to write refers to the type of oscillator, and you declare it like this. This HS oscillator line refers to high-speed oscillator, and I just wrote this part right here before I started to actually show you this video, because I wanted to save on time. So the thing is that I have on my development board right here a 20 megahertz external oscillator, and I just want to use that. The manual for this PIC microcontroller says that external 20 megahertz oscillator can be achieved by setting this pin HS OSC. So I'm just going to do that. To declare another fuse, I just use the same line, and I add here this will make the code protect fuse to be disabled. Then I'm going to add this. This makes the low voltage programming to be off, because we don't use that low voltage programming thing. This instruction disables the brownout protect. This pin right here, this fuse right here enables the memory clear enable pin. In my configuration, as you will see on my website, I have a resistor connected between the plus of the system, so the VCC of the system, and the pin designated for memory clear enable. So the next fuse is actually the okay, and almost the last one, it's the watchdog timer, which we're gonna set it off for this example, because maybe we're gonna treat this topic in a future video. I'm not sure if I forgot something or not. It should be 1, 3, 4, 5, 6, 7. Yep, that's it. Just forgot to put this operator here. Okay, so we're done declaring these fuses. Now we would like to declare some variables, and we can do this declaring them one by one. I'm just going to show you here how to declare a block of variables, because in my point of view this is the easiest way to do it. So you're going to write C block like this, and you're going to declare a length of this vector, and that's going to be in our case let's say 20 bytes. Of course you can declare in this interval of 20 variables of 1 byte each, or you can declare some other charts or some other things, and we're just gonna write here, like for example we're gonna declare a n var1 for instance, and 2. Okay, after you're done with declaring the variables, you're gonna end this block of variables by putting this end C command right here. Then after you're done declaring this block of variables, the next thing you want to do is to set your ports that you're going to use for sending data out and reading data in. We're going to use the port A as an input, and the port B we're going to use it as an output. So before we actually start to declare the type of inputs we want for the ports and the type of outputs, because if you look in the data sheet of the microcontroller, you will see that you are able to change and select between multiple functions of the respective pin. I advise you to write the command for clearing the port values, and that's the command. You're gonna write clear file, clear f, it's coming from clear file, and then you're gonna write like this, because in the eventuality that one of your ports has some enable bytes on their registers on the output, and you're gonna set like that respective port as being an output or an input for a very short period of time, a few microseconds there, you will have that pin enabled, and we don't want any glitches and any pulses on the output or the input pins. That's why I advise you to set these pins before you actually configure them. Okay, I'm gonna write here this is actually how you declare a block of variables. Okay, moving on. The first thing you need to do is, for instance, to disable the function of comparator on the input pins, and you want to enable the pins for functioning as input output. To do that, you just you're gonna write a number into the working register, and that's going to be something like this. By writing, for instance, this number into the working register and then moving the working register into the cmcon register, that makes the following command. So it's disabling right here. So this command actually disables the comparators on your pins, and it's enabling the pins for functioning as inputs and outputs. The next thing we want to do is to set the trace registers, and the trace registers are responsible for the direction of the logical data you're receiving or you're sending into the pins. So basically, if you write in the trace registers a 1, you're setting that pin on your port to be considered a input, and if you're writing in the trace registers some zeros, you're considering those respective pins as being outputs. So this is what we're going to do right now. We're going to move some numbers into the trace registers. So let's just declare it like this. We're going to declare it being as byte, because in this way you will be able to see better what's happening here. So I have, as you can see, 1 byte right here, and we're going to move this byte into the trace A register. This entire command here makes the following pins from 0 to 4, 5. Yep, from 0 to 4 as inputs, and because I have this configuration of hardware, in my case I read the trace 5 as 1 always, because my port A number 5 pin is always connected to the plus, and I will always read it as 1. Okay, and the following thing, it's basically exactly the same command, just gonna copy paste it to save on time, and I just need to set the trace B port right now. So I'm just gonna write 0 into the trace B register, and this will set the pins from 0 to 7 as outputs. Now there is a problem with setting these trace registers. In order to have access to them, I need to be in a different bank of memory. Basically, these areas of the memories can be accessed in different locations of the memory map by setting some flags that will allow me to access that part of the memory. And I'm gonna do this by modifying 2 bits into the status register. I'm gonna do this by modifying the single bits. Yep, and this sets bank 1 memory, and of course I have to make sure I have to make sure that RP1 is actually set on 0 and RP0 is actually set on 1. BSC in assembly language means you can remember it by saying bit set in file. So, and before I change these 3 registers, I need to set a different bank of memory, and after I set the 3 registers I have to go back to the initial bank of memory. So I'm gonna almost write the same thing, but I'm just gonna return the state of these bits from the register. I'm just gonna copy paste it. So instead of setting this bit, I'm gonna clear it now, and with this command right here I'm actually returning to the same page of memory. I think I'm gonna keep this block together right here because you'll be identifying it better if I do so. Okay, I don't know why I have this here. I'm just gonna move it here very close to the fuses. In this way it's gonna stay there, and it will be easier for you to orientate. Okay, after setting these 3 registers and setting basically the pins of the port B as inputs and setting the pins of the port setting the pins of the port B as outputs and setting the pins of the port A as inputs, we're gonna basically start our main loop. So you can write some always some comments to help you remember what you've been writing here. You're going to need some labels, and we're going to put a label here that says repeat. And when you finish the main loop, you're going to have an instruction that sends you back to the repeat label. There you go. So this is basically the end of the main loop. Okay, after the main loop is completed, your program count, your pointer will never pass this point. You can set another command for the compiler, and this other command basically ends the section of code that you're writing here. Okay, we're gonna write our main loop, and our goal for the main loop is to read the value of the port A and to write this value of the port A into the port B, and this port B is basically our output port, and we will see the LEDs turning on right here when I press some of these buttons right here that are corresponding to the port A, which we set as inputs. Okay, to do this we're gonna have to transfer the information from the port A byte register basically into the working register, and to do this we're gonna write move file into working port A. Then we're gonna move the information from the working register into some file, and this file is gonna be basically our port B register. Okay, so it's gonna repeat this loop very fast, and every time it sees one of these buttons from the input being pressed, being logical 1, it will turn on one of the first 5 LEDs that we have on port B. By the way, the labeling of the LEDs, it's from left to right, so it's 0, 1, 2, 3, etc. Okay, so we are only using the first 5 inputs, the first 5 bits, counting with 0 from the port A, because number 5, number 6 and number 7, these pins are already used for something else, and this is basically how you write your code, you know. This is how it should look like. And right now in this stage, if I compile it and write it on the microcontroller, it will do its job. Now some of you might ask why I wrote this, why I declared these variables right here, and to make this as a complete exercise and not leave these variables out, I'm just gonna use them. So instead of moving the information directly from the port A register into the port B register, I'm gonna pass it through one of these variables. So I'm just gonna move the working into this file and var1, and now from this file I'm gonna move it again into the working register, and var1. Okay, and now I'm just gonna write again the information from this variable into the port B. It's just an exercise to make us understand better how these variables, these memory locations are working. Okay. Oh, I already wrote this. Let's compile it and build the project, see what happens. I have some errors. We're going to check them. Oh, all these errors are because I accidentally wrote a different type of microcontroller here, as you can see. Let's hope that will fix it. I forgot to add these. Oh, I always forget. Yeah, let's try it again now. Yep, seems like something is still not working in line 5 here. Yep, this one. Okay, so it seems it's working. Now, maybe you're using MPLABX and you're wondering how can I see the memory usage here in the left corner, because this comes as a facility in this program, and I saw that this is an issue and many people are asking there on forums, how can I do it? Okay, this section right here has a button here in the corner. It looks like a key, like a wrench and some bolts. If you press on it, it will lead you to this option window, and here in this option window you just click on loading right here, and then you check this small box right here that's saying load symbols when programming or building for production. This slows the process, but in our case it's not very important because we just compile from time to time. Now, after I wrote this program and I built it, my integrated programmer has actually noticed that I modified this program that I previously selected here, and it asks me the hex file has been modified. Would you like to load or to reload this modified code? Now we're just going to click on yes. After I reloaded the code in this window, I just hit the program button. My pickit it's already connected, so I just hit the program button. It took like a 2 seconds or so to program the microcontroller because it's a very short code. And now I have the microcontroller programmed here. In order to be able to test it, I'm just going to move it from here, from this programming location into this launchpad location right here, and this is my power button. I'm just going to hit it. This LED right here signifies that I have power on this side of the board and the microcontroller is already powered. Now if I press these buttons, I should be able to see these LEDs turning on. Check it out. I can even press multiple buttons in the same time, and the code, the program will just read the entire value of the port. It will write it into the register byte, and then it will just copy that byte into this variable that we set, and from this variable it will just move it again into the output port, into the port B. So I just hope you liked it, and this longer video, it's a very good introduction for rookies, for people who never had the opportunity to practice with microcontrollers. And of course, now that you know how to write a hello world program, this leads the way to some other major projects you might like to involve in. I have to remind you that in the same way you can actually program multiple types of microchip microcontrollers. So all you have to do is to change this include line right here and to select from the programming environment the respective type of microcontroller that you want to use. So assuming that the microcontroller you want to use has already these ports, because they have pretty similar hardware components inside, pretty similar schematics and component blocks, you can successfully use this type of program for programming, for instance 16F84s or 16F819 or some other microcontrollers. So I just hope you enjoyed this video, and just stay tuned for more videos. If you like the video, just don't forget to subscribe to this channel and to leave your comment below. Let me know what you're thinking about it. So until next time, see you guys.